So let's move to the last subtopic, which is the titration. The most important things in this part is you have to be able to determine the pH at 4 different points during the titration, which is initial, before the equivalent points reach, at the equivalent point, and after the equivalent point. So titration is actually a method in which one of the reagent that we know their concentration is added or is reacted into another solution with the unknown concentration until the endpoint is reached. Okay, so basically the purpose of this titration is actually to determine the concentration of a solution that we don't know their concentration by react it with another solution that we know their concentration. Okay, and endpoint is a point in which indicator starts to change its color permanently. Equivalent point, it is a point at which the equal amount of the acid and base has been reacted. It is actually also depending on the mole ratio during a reaction. If the mole ratio is 1:1, means that they will reach this equivalent point when they have equal amount. However, if their ratio is 1:2, then the equivalent point is when they achieve that ratio. Okay, so in the titration, okay, the solution that we know their concentration and it is normally in the burette is what we call as a titrant. Okay, and then the titer is the solution with the unknown concentration and it is located in the beaker. But it is not necessarily that the known one will be in the burette and the unknown one in the beaker. Sometimes they are opposite. Okay, for example, in this figure that is given, okay, our titrant is the sodium hydroxide and then the titer is the HCl. Okay, titer is the one that is in the beaker. So this is the setup of the titration. So let's look at the first type of a reaction, neutralization between the strong acid and strong base. If we look at to the titration curve, there are three distinct regions that we have to remember. Okay, firstly, the pH of this solution will start out low. Okay, it is 1 or less than 1. Okay, it is because initially the pH that was measured is the pH of the acid in a conical flask before the addition of any strong base. And then we look at to the pH that increased gradually until a point the pH increased steeply 6 to 8 units, okay, in a vertical region. And then this is the third region of this titration curve when the pH increases slowly until a point, then the pH will constant. So this is the initial pH and then it is increased slowly. This is also before the equivalent point and then increased steeply until it passed the pH at the equivalent or until it passed the equivalent point, and then this is when we start to have a pH after the equivalent point. So let's look at to the calculation part. Okay, as we know that we have to be able to determine the pH before, at and after the equivalent point. Okay, let's answer this question. Calculate the pH during the titration of 25 ml of 0.1 HCl after the addition of 0.2 molar of sodium hydroxide. So let's illustrate what is happened during this reaction. Okay, since that we know the amount and also the concentration of the HCl, normally it is the substance in a conical flask. So in this conical flask, we have HCl, okay, with the concentration of 0.1 molar, and the volume is 25 ml. And then we have a pH meter, and we also have a burette, okay, and in this burette we will have a sodium hydroxide. So when you get a question, firstly you have to identify the solution in a conical flask and the solution in your burette. Okay, since that we know what is the exact volume and also the concentration of the HCl, we know that HCl is the one in here because it will be constant, it will not change. The one that is changing will be the volume of the sodium hydroxide that is added. We don't have the exact volume here that is given. So question A asks us to calculate the pH after 0.0 ml of the sodium hydroxide is added, means that before we add any sodium hydroxide. So look at to the condition before any sodium hydroxide is added here. What we have and what is measured by this pH meter is actually the pH of the HCl only. Okay, so it means that we have to calculate the pH of this HCl. So we know that for A we have HCl only that is measured, and it undergo dissociation because it is a strong acid, so it is 100% dissociated into H plus and Cl minus. Since that the concentration of the HCl is 0.1 molar, means that concentration of the H plus will be 0.1 molar, chloride also 0.1 molar. So we can strictly calculate the pH is equal to negative log concentration of H plus. We know that H plus is the same as the H3O plus. So it is equal to negative log 0.1. Then we press the calculator, we'll get the pH is equal to 1. B is when 10 ml of the sodium hydroxide is added. Now we start to have a sodium hydroxide that is going down here and reacted with the HCl in a conical flask. So we have to know what is the amount of the HCl. So N of the HCl is equal to mV over 1000 is equal to 0.1 multiply with the 25 ml over 1000, so it is equal to 2.5 times 10 power of negative 3 mole. And then the amount of the sodium hydroxide added is also mV1000, which is equal to 10 multiply with 0.2 over 1000 equal to 2.0 times 10 negative 3. And then we have to construct the reaction table. So this is a reaction between HCl plus sodium hydroxide turns to NaCl plus H2O. They are aqueous, aqueous, aqueous liquid. And then our reaction table consists of the N initial. HCl is 2.5 times 10 negative 3. Sodium hydroxide is 2 times 10 negative 3. And NaCl initially is 0. H2O dash. Then N change is, when we look at to this, we have to identify the limiting reactant. So HCl we have 2.5, while sodium hydroxide only 2. So that sodium hydroxide is the limiting reactant. It will completely consume during a reaction. So it will be minus 2.0 times 10 negative 3, minus 2.0 times 10 negative 3, and plus 2.0 times 10 negative 3, and so N final is equal to 5 times 10 power of negative 4 left of HCl, no more sodium hydroxide, and 2.0 times 10 negative 3 mole of the sodium chloride form. And then we can calculate the concentration final. 5 times 10 negative 4 divide with the total volume. So we also can calculate the V total here is equal to, we have 25 ml HCl plus with 10 ml of the sodium hydroxide. So the V total is equal to 0.035 liter. So here is over 0.035 liter. And sodium chloride concentration is also 2 times 10 negative 3 over 0.035 liter. So the concentration final of the HCl is equal to 0.0143. Finally, after the reaction completed, okay, what's left in our vessel or our conical flask is actually HCl in excess, 5 times 10 power of negative 4, and 2 times 10 power of negative 3 mole of the sodium chloride that has been formed. So we have a strong acid and its salt. So we know that this is a strong acid, strong base reaction, and the salt will be neutral salt, so that the pH that is measured by the pH meter is actually contributed by the HCl, which is the strong acid that we have. Can calculate the pH. This is the concentration of the HCl. Okay, so HCl dissociate to H plus plus Cl minus. So HCl is 0.0143, 0.0143, 0.0143. So pH is equal to negative log H plus concentration negative log 0.0143 is equal to 1.84. So this is the pH after 10 ml of the sodium hydroxide is added. C is when 12.5 ml of the sodium hydroxide is added. So first we have to know the amount of the HCl that we have, which is 2.5 times 10 power of negative 3 mole. And then the number of mole of the sodium hydroxide that is added is mV1000. So 12.5 multiply with 0.2 over 1000. The amount is 2.5 times 10 negative 3 mole. And then V total is equal to 37.5 ml. Okay, so we construct the reaction table. So a reaction between HCl and NaOH produce NaCl plus with H2O. So N initial HCl is 2.5 times 10 negative 3. Sodium hydroxide that is added is also 2.5 times 10 negative 3. When we look at to the ratio, their ratio is 1 to 1, and then the amount of them also equal, means that this is at the equivalent point. And then NaCl initially 0 dash for H2O, and change, they are all reacted, so they are all minus 2.5 times 10 negative 3 minus 2.5 times 10 negative 3, and ACl added positive 2.5 times 10 negative 3 dash for H2O. So N final will be 0 for HCl, no more left, 0 for the sodium hydroxide, and what we have is only the salt that is produced. So we have to remember that at the equivalent point of any reaction, either strong acid, strong base, weak acid, strong base, strong acid, weak base, at the equivalent point, only salts that is present. Okay, no more acid or base, only salt that is present at the equivalent point. And then we know that this salt is a neutral salt because it is a product of a reaction between strong acid, strong base. None of the ion during the dissociation of the NaCl that will further hydrolyze. So the pH will be equal to 7. So the pH after 12.5 ml of the sodium hydroxide is added is equal to 7. Let's look at to D. It is when 20 ml of the sodium hydroxide is added. So we know that the initial amount of the HCl is 2.5 times 10 power of negative 3 mole. And then N for the sodium hydroxide is equal to 20 ml multiply with 0.2 molar over 1000 is equal to 4 times 10 negative 3 mole. And then the V total is equal to 25 ml of the HCl plus with 20 ml of the sodium hydroxide, so it is 45 ml, which is equal to 0.045 liter. Okay, let's construct the reaction table. We have a reaction between HCl and NaOH turns to NaCl plus H2O. So N initial HCl is 2.5 times 10 negative 3. Sodium hydroxide that is added is 4.0 times 10 negative 3. 0 NaCl dash for H2O. And change, let's compare between these two. Okay, we know that the amount of the HCl is less than sodium hydroxide, so HCl will be the limiting reactant, it will completely consume. So the amount that is changed for both is negative 2.5 times 10 negative 3, negative 2.5 times 10 negative 3, plus 2.5 times 10 negative 3 dash for H2O. So for N final, it will be 0 for HCl, no more left. We will have 1.5 times 10 power of negative 3 sodium hydroxide left, and 2.5 times 10 power of negative 3 mole of the sodium chloride that is formed. So let's check what we have in this reaction vessel after the reaction has been completed is the salt, and we know that it is a neutral salt and also a strong base. So the pH that was measured by the pH meter is actually contributed by the strong base sodium hydroxide. We can calculate the concentration final is equal to N over V, which is equal to 1.5 times 10 negative 3 over the total volume that we have calculated, 0.045. So it is equal to 0.033 molar. So this is the concentration of the sodium hydroxide left in a conical flask. We can calculate the pOH and also pH. So pH is equal to 14 minus pOH. So it is equal to 14 minus negative log concentration of the hydroxide ion, which is the same as the concentration of the sodium hydroxide, is 0.033. So we'll get the answer is equal to 12.52. This is how we calculate the pH of a solution during a titration between a strong acid and strong base. So from the pH that we have calculated, we should be able to sketch a titration curve of the reaction, the pH versus volume of the NaOH added. So the pH start low, around 1, gradually increase, and then steep increase, and gradually increase until a point it is constant. This is the equivalent point when the value is around. So this is a titration curve that was plotted. Okay, it shows how the pH changes with the amount of the sodium hydroxide that is added to the system. Okay, as what we calculate just now, the initial pH before any sodium hydroxide is added is 1, and then it is increased slowly. Okay, when 20 ml of the sodium hydroxide is added, we have here at this point, and then increase gradually until a point it has a steep increase. Okay, and then this is the equivalent point, and gradually increase